Today's lesson is to find the probability of independent events and find the probability of dependent events. Adam's teacher gives the class two lists of titles and asks each student to choose two of them to read. Adam can choose one title from each list or two titles from the same list. If he chose one title from each list, choosing a title from one list does not affect the number of titles to choose from on the other list. The events are independent. If you choose two titles from the same list, choosing a title from one of the lists changes the number of titles that can be chosen from the same list. The events are dependent. Events are independent events if the occurrence of one event does not affect the probability of the other. Events are dependent events if the occurrence of one event does affect the probability of the other. Tell whether each set of events is independent or dependent. Explain your answer. A. You select a card from a standard deck of cards and hold it. A friend selects another card from the same deck. These are dependent events. Your friend cannot pick the card you picked and has fewer cards to choose from. B. You flip a coin and it lands heads up. You flip the same coin and it lands heads up again. These are independent. The result of the first toss does not affect the sample space for the second toss. Tell whether each set of events is independent or dependent. Explain your answer. A and B are for you to try on your own, and then you can check back for your answer. A number cube lands showing an odd number. It is rolled a second time and lands showing a 6. These are independent. The result of rolling a number cube the first time does not affect the result of the second roll. B. One student in your class is chosen for a project. Then another student in the class is chosen. These are dependent events. Choosing the first student leaves fewer students to choose from the second time. Suppose an experiment involves flipping two fair coins. The sample space of outcomes is shown by the tree diagram. Determine the theoretical probability of both coins landing heads up. The first coin you can see heads, tails. Second coin heads, tails, heads, tails. There are four possible outcomes in the sample space. You could have heads and heads, heads and tails, tails and heads, tails and tails. Only one outcome includes both coins landing heads up. The theoretical probability of both coins landing heads up is 1/4. Now look back at the separate theoretical probabilities of each coin landing heads up. The theoretical probability in each case is 1/2. The product of these two probabilities is 1/4, the same probability shown by the tree diagram. To determine the probability of two independent events, multiply the probabilities of the two events. Probability of independent events. If A and B are independent events, then the probability of A and B is the probability of A times the probability of B. An experiment consists of randomly selecting a marble from a bag, replacing it, and then selecting another marble. The bag contains 3 red marbles and 12 green marbles. What is the probability of selecting a red marble and then a green marble? Because the first marble is replaced after it is selected, the sample space for each selection is the same. The events are independent. The probability of drawing red and then green is the probability of red times the probability of green. So the probability of selecting a red is 3 out of the 15 marbles, and the probability of selecting a green is 12 out of the 15 marbles. So if we multiply 3/15 times 12/15, we get 1/5 when we reduce times 4/5, which gives us 4/25. A coin is flipped 4 times. What is the probability of flipping 4 heads in a row? Because each flip of the coin has an equal probability of landing heads up or tails, the sample space for each flip is the same. The events are independent. So the probability of flipping heads, 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 heads is the probability of heads times the probability of heads times the probability of heads times the probability of heads. The probability of landing heads up is 1/2 with each event. So 1/2 times 1/2 times 1/2 times 1/2 is 1/16. An experiment consists of spinning the spinner twice. What's the probability of spinning 2 odd numbers? This is for you to try on your own, and then you can check back for your answer. The result of one spin does not affect any following spins. The events are independent. With 6 numbers on the spinner, 3 of which are odd, the probability of landing on 2 odd numbers is the probability of odd, and odd would be probability of odd times probability of odd. So the probability of landing on an odd is 1/2. 1/2 times 1/2 would be 1/4. Suppose an experiment involves drawing marbles from a bag. Determine the theoretical probability of drawing a red marble and then drawing a second red marble without replacing the first one. For the first draw, you can see there would be 3 red marbles and 6 blue marbles. For the second draw, if you drew out one of the red marbles, there would only be 2 red marbles and 6 blue marbles. The sample space for the second draw is not the same as the sample space for the first draw. There are fewer marbles in the bag for the second draw. This means the events are dependent. The probability of drawing a red marble on the first draw would be 3 out of the 9 marbles, or 1. The probability of drawing a red marble on the second draw would be 2 out of 8 marbles, which is 1/4. To determine the probability of the 2 dependent events, multiply the probability of the first event times the probability of the second event after the first event has occurred. So the probability of dependent events, if A and B are dependent events, then the probability of A and B is the probability of A times the probability of B after A has already taken place. A snack cart has 6 bags of pretzels and 10 bags of chips. Grant selects a bag at random, and then Iris selects a bag at random. What is the probability that Grant will select a bag of pretzels and Iris will select a bag of chips? To understand the problem, the answer will be the probability that a bag of chips will be chosen after a bag of pretzels is chosen. List the important information. Grant chooses a bag of pretzels from 6 bags of pretzels and 10 bags of chips. Iris chooses a bag of chips from 5 bags of pretzels and 10 bags of chips. The reason the pretzels is down a bag is because we're assuming Grant chose 1 bag from the pretzels. If it's helpful to draw a diagram, you can see that the sample space that Grant gets to choose from, they have all the pretzels and chips, and then Iris, there's 1 less bag of pretzels. After Grant selects a bag, the sample space changes, so the events are dependent. To solve, the probability of pretzels and chips would be the probability of pretzels times the probability of chips after Grant chose the pretzel. Grant selects one of the 6 bags of pretzels from 16 total bags. Then Iris selects one of the bags of 10 chips from 15 total bags. So 6/16 times 10/15 gives us 600 240ths, or 1/4. The probability that Grant selects a bag of pretzels and Iris selects a bag of chips is 1/4. If it's helpful to look back, drawing a diagram helps you see how the sample space changes. This means the events are dependent, so you can use the formula for probability of dependent events. A bag has 10 red marbles, 12 white marbles, and 8 blue marbles. 2 marbles are randomly drawn from the bag. What is the probability of drawing a blue marble and then a red marble? This one's for you to try on your own, and you can check back for your answer. The answer will be the probability that the red marble will be chosen after a blue marble is chosen. A blue marble is chosen from a bag containing 10 red, 12 white, and 8 blue, and then a red marble would be chosen from a bag with 10 red, 12 white, and 7 blue. To make a plan, if it's helpful, you can draw a diagram. In the first one, you would see that it has all of the red, white, and blue, and in the second one, you can see that it would have 1 less blue. After the first selection, the sample space changes, so the events are dependent. For solving, it'd be the probability of red and blue equals the probability of the blue times the probability of red after blue. So probability of blue would be 8 out of 30 times the probability of red after blue would be 10 out of 29. 1 of 8 blue marbles is selected from a total of 30 marbles, and then 1 of 10 red marbles is selected from the 29 remaining marbles. So you multiply them together and you get 8 870ths, which would reduce to 8 87ths. The probability that a blue marble is selected and then a red marble is selected is 8 87ths. If you want to look back, drawing a diagram helps you see how the sample space changes. This means the events are dependent, so you use the formula for probability of dependent event.